Okay, so I just got done attempting to make the second video in the series and realized um, when I was really far along, after recording about 2 hours from different video sources, um, I realized that I made a mistake in the first video. And so uh, this video will be about fixing that mistake. And so I actually made a pretty large error early early along when I was um, showing how to do the alignment drills. Actually, that wasn't really an error, but when I was making the second video and actually applying those alignment drills and trying to align the board, after I flipped it, I realized that, I realized at the time that I had done a poor job with the alignment drills and such that they were all they were all in the same x-axis value, right? So um, I don't know. I flipped them over the wrong axis. I don't even really remember at this point what I all that I did wrong, because the ultimate solution for that, and I recorded all of that. I'll be sharing it. Um, but the solution to that was to do the alignment drills, the alignment holes in such a way that I had four corners. So instead of um, what I had before was two dots or two drill holes very close to the origin, um, and then I mirrored over the x-axis. So then I then got those at the top of the circuit board. But there are two holes there and two holes there, and then but I actually mirrored the board over the y-axis, or I mirrored the bottom layer over the y-axis, and so I have to flip the board that way. And so by doing so, and I had all the holes on the left side of the board, when I flip it, all the holes are now on the right side of the board. So it makes it really challenging to get that initial alignment. Um, so I, for whatever reason, didn't think that that was what had happened, and I thought that I was just misunderstanding my intent. So I then proceeded to align the board to the wrong holes, and cascading failure happened there. So I aborted that and fixed it live. Recorded that I fixed when I fixed it. But and then I finished the entire process. I milled through the entire board and realized, oh no, I don't actually have full isolation on some of my traces. And that was because in the beginning, in the first video, I mentioned that I had set the tool to 0.498. And that was really important to note that later on in the CNC milling process, I had said something that wasn't true. Actually, I said that it doesn't matter that you do this now, because later on I know that my tool is just 0.5 millimeter anyway, and it's just going to blow through this area. Well, the problem is that FlatCAM knows that too, and it knows the diameter of your tool, and it knows that technically there's only 0.498 millimeters between these two, so your bit is not going to fit between them. So it didn't actually do the geometry to make the bit go between certain areas on the traces that I need it to. So the fix for that would be there's two ways you could go about that. You could either change the design, or trick FlatCAM into thinking you're using the right bit size so that it just happily goes through. And that's actually the approach that I like to take with this. I don't want to change the design. I like that they have basically 0.5 millimeter what's the word separation between them. I like that, and I don't want to have to change the whole design to then make the traces just a little bit smaller and everything just a little bit smaller, and then that cascades out to the entire design. Now all the traces are smaller, instead of just I can go and change in FlatCAM. I should show you the board itself. The problem. Anyway, this you can tell some of those traces right there. They touch each other. So I went to test these vias that I was pounding in, and well, they all look really pretty on that side, right? But then I went to test them on that side and realized some traces are touching each other, and then I saw it. I was like, oh no. I realized what I did, and it was um, something that I can't really recover from in the moment because the first video needs to be corrected. I have to make some corrections to the process in general. So that's what I'm going to do here. I have FlatCAM here, and so the big problem is, well, let me hide some of these. Actually, I got to get rid of all of them. The outline is still good. Actually, I did make a mistake with the outline as well because my drill bit's actually 2.2 millimeter, not 2.4. So the cutout drills are good. Yeah, all the isolation, everything's bad except for the drills. Board cutout's bad. Bottom layer's bad. Top layer's bad. Drills are good. All right, the Gerber files are obviously they are what they are. So I'm going to go through this and not use my script this time, so you get a better idea. Now I've got a database of tools. Now this is sort of the problem here. So I transfer this tool. I have a 0.5 millimeter tool, but my traces are only separated by 0.498. I'm just going to fudge it and say my tool is 0.49 millimeters in diameter, so that it fits everywhere, or so that FlatCAM thinks it'll fit between the traces. And then another problem was I'm trying to balance the number of passes here with the overlap, because if you think about it, I have a half millimeter drill bit. If I overlap by 50%, I'm only moving 2.5 millimeters, or no, 0.25 millimeters, so a quarter millimeter when I go to the next pass. So for 10 passes, that's 2.5 millimeters. But it just takes so long to do 10 passes around. So I was trying to do less overlap. Even a 60% overlap, like 10 passes, you don't get to 2.5 millimeters by the 10th pass. It's I don't even want to calculate it right now. It's just annoying. So I tried to go down to 3 passes. I think 3 passes is still okay. I honestly do. I just don't think that the bit was allowed to go between the traces like I expected it to. But that's easy to see, and I should have caught that. So let's. I'm first going to do the traces on the bottom layer. It's more obvious there. If you look at it, it's mirrored, but where these two come together, it's not isolated there. So that's just one place I can look after I do this again. Let's see. So yeah, look. So now, you know what? I should go back and do it the wrong way again just to see. If I pick my tool as is, 3 passes, 50%. Right. This is what we had before. It was actually done in the script, right? So 3 passes, 50% here. So I really should change this if I'm going to change it, but I need to change the tool diameter here if this works. But now if I generate the geometry with the right tool size, oh, I did it on the top. Bottom layer. Yep, see? I should have seen this. It's always best to check your geometry. Make sure that the tool is going to go the place you want it to go. This is pretty obvious. This was going to be all copper here because this not going to tell the tool to go that way, and it's because of the tool size. And now it's just annoying because I literally said out loud the wrong information. But if you change this to 0.49, it doesn't really matter the physical versus the setting, if that makes any sense. So anyway, I'll go through and redo all of this a little bit quicker than before. Actually, not a little quicker than before because I'm just going to fix the script. This was 2.2, passes 4.9. All right. I'm not going to go redoing all this by hand. Starting over. So 0.49. Everything else was good. Although I did miss the end XY on some of these. I don't know if that's in the CNC job. I guess it was because it was on the ones that I did manually, probably. Anyway, I'm going to run this again. I didn't change the design at all, but I did change the alignment drills. I did those manually. And so what I did for that was I clicked to find those. So this, you know, if you were doing this for a new design, this script is going to have to be modified, or the alignment drills can be done manually every time. But so what I did was I picked, oh geez, I don't have the design up now. I picked the bottom left corner, the origin, and I went down one, so it was 0, -1, and then still -1 on the y-axis, but I went to 29. Is that correct? Yeah, and then I mirrored that over the x-axis, so that I'm left with a box. And the trick to it is that 29. Oh geez, there's 28. It was 28. It's because the design is actually 28 millimeters. The microbus adapter, this board itself is 28. It's supposed to be, the design itself is 28 millimeters. I don't know physically I milled that wrong. I did because the cutout bit was the wrong size. But what am I saying? Because the design is 28, I go, you know, the alignment drill being at 28 on that side, once it gets flipped, because I'm flipping it on the x-axis, that 28 becomes 0, because I'm flipping it all the way. And so when I go to align it, I'm much closer to the origin. And so that was sort of the problem, is that I was so far away from the origin with my alignment drills once I flipped it in the original design that I just was like, I didn't want to have to. It's so easy to be able to align things when you have it close to the origin, because you go to the origin, or you find where that hole is, and then all you have to do is go up 1 millimeter. Now you're at the theoretical origin, and you set the origin. Now when you start aligning things, your origin is set. So once you have all 4 holes aligned, you go to the corners, you go to each corner one at a time, and over and over and over again until everything looks good. And then that's when you can send your job. You lock everything down. That's when everything's aligned. But it's so much more difficult when it's farther away from the origin, because that first hole alignment, it would be like 29 point. It was at like 29 point some millimeters away. Like it was just impossible for me to tell the machine to go to that coordinate negative. It was just a really messy situation. So it's a lot easier to set them manually, and then when they mirror, you get those translated coordinates back to the mirrored version, and 28 becomes 0, and etc. It's just a lot easier to reason about. So that's all. It's all good. Top layer passes. I'm still going to do 3, 50% overlap. Might increase that to 4, but again, don't really have to. It's all isolated as long as the geometry is good. Mirror the bottom layer on the y-axis. Yep. 4.9 passes 3 overlap. Okay, gaps 8, gap size 1 millimeter, 2.2. So the other mistake that I made was the board outline, and it cut just fine. Well, first of all, I made 2 mistakes with the cutout. Number one, the board outline, I had the wrong diameter drill bit or milling bit, side cut bit, and it worked, but the geometry was such that FlatCAM tried to align the bit with the edge of the board cutout line. So when it actually cut it out, it's exactly 28 millimeters. So it's like, because I said that the diameter of the bit was 2.4 millimeter, that margin is off, because the tool is going to be in the same position, but it's thinner now. So about 0.2 millimeters on each side, 0.4 millimeter total, all the way around the board is how much bigger it was. So you can sand that down, and that's okay. It's not a huge deal. And actually, I do sand it kind of as a general rule. So maybe that's something I should keep doing, because if I did it exactly as so, some of this copper would be gone probably, because that's probably the 0.4 millimeter. That doesn't matter. We'll use the right tool size. There's a way to add a margin if you really wanted to do that, so you should have the right tool size. Okay, so do the CNC job, the top layer. I think this might be, I don't see the end. No, there it is. NZ, index Y. This is like, it's a really good setting to have, because as soon as the job is over, it goes back to the origin. Because sometimes when you're changing the drill bit, you knock one of the edge sensors, or the. So I have this script saved here. Upload that. All right. So I'm going to run the script again and see what I get. All right. So remember from before, that script is all it really takes to get 90% of the way there. But there's a lot of noise, so I have to disable some of this stuff. Just view it one at a time. All right, got the top layer isolation, looks pretty good. Let me hide the bottom layers for a second. Okay, that looks good. So the bit's going to go between all of these traces. Everything looks pretty good there. Actually, don't know. Did it? I did a pretty good job here, because I guess because the these traces do happen to be half a millimeter apart. Okay, so that's good. Enable that. Okay. Let me see. Hide these in the meantime. Alrighty. Interesting. I realize that trace is so close to a hole. Cut that out. I didn't realize that trace was so close to a hole there. It's not supposed to be. Something's wrong. Oh, it's not. Duh. I mean, this is the mirrored version. It's not milled that way. Okay. So I was just verifying to make sure that the bottom layer is isolated. Okay, that looks pretty good. All right. So now I just need to generate the instructions for the drills, because the script doesn't do that. And this, it does have it. I actually already have the CNC code for this, so I guess I'll save it again, just to be thorough. Okay, I think that's everything. Let's just go through, double check. All three layers. We've got drills for everything for the vias and all. We've got alignment drills. They're in the corners. 0, -1, right? Yeah. And then this one is 28. Yep. So what I was saying, you can see that if you flipped this vertically, or on the vertical axis, on the y-axis, this drill hole here, visibly moves to the left side, and then you have to move up one to get to the origin. So then you've mirrored it, and like it's just so much easier to you can sink the drill down into this hole physically, line the board up, square things up a little bit, and then lift it up and go 1 millimeter up and set your origin. And now when you move over 28 and down one, you're at where that hole, the other hole should be, this hole, and then you move and you move it around a little bit, and then you move to the other corner. You go just corner to corner to corner, and then everything's aligned. You lock everything down, and that's when you mill it. So I just needed to go through and fix this step before moving on to the next step again, and finalizing and actually milling all of this, because a lot of this was bad. So I'm just going to upload this separately as an amendum of some sort, and the rest of the series, I guess I'll just go off of this design and that script. So that's that. Thanks for watching.